I need to do that so I can see the buttons.
Okay, here we go. All right, so show of hands, how many of you folks have used Meshtastic? So 2, 3. Okay, well that makes it a really good topic, I guess. So that's good. All right, so yeah, we're going to talk about how fantastic is Meshtastic. Oh, there's an alternate logo there. This is another one that I created with Google. So 50 agenda. Yeah, I always love the stuff it comes up with. You know, there's like a joystick down here, and there's boards and a bunch of stuff sitting around. There's a Game Boy. Yeah. I've got coffee. I don't know if there's a donut anywhere. There's a sandwich. Anyway, so we're going to talk about mesh networking 101. So I'm just going to give you an overview of what mesh networking is, because a lot of people are confused about the term in general. Then we'll talk about, there's kind of two competing technologies that are very similar. There's Meshtastic and there's MeshCore. And I'll talk about the differences and similarities between the two of those. There's also a licensed mode for both of those, which means that if you're a licensed amateur technician or above, you can use a special series of capabilities, which for some people is not a capability or not a plus. For some people it's actually a minus. So we'll talk about the pluses and minuses of running in licensed mode. Then I've got some devices. We'll talk about some of the various devices that support Meshtastic. I have 3 different types here that I'll pass a couple of them around so people can look at them, and then we'll do a quick demo. Oops. Okay, so let's talk about mesh networking. So if you think about a traditional network, literally the internet is the world's largest mesh network. You know, if you think about the term of a mesh, that's exactly what it is. A mesh is, you know, in kind of physical terms, a mesh is like a net, right? It's a bunch of threads that are connected to one another. And that's really what a real network is. And then, so even if you look at your home network, where you've got a bunch of different devices, they're all connected to each other through a piece of hardware. It could be a Wi-Fi router, it could be a hardware router, right? And so that's technically a mesh because they're all connected to each other. So there's really a couple different types of meshes, which I'll talk about in a minute. But you know, traditional networking is actually a mesh itself. And the internet is the biggest mesh because it's just made of meshes connected to meshes all over the world, right? All right. Now the problem with a traditional mesh network is that they tend to be dependent on a piece of hardware in the middle to make them work. Right? So it could be a router, it could be a backbone like the internet, whatever it is. And so when you get into a disaster situation, oftentimes those networks fail, right? Because that infrastructure dies. And so that's where, you know, kind of the term peer-to-peer, so one device to another communications, becomes really handy. So we'll talk about that in 1 second here. All right, so a simple mesh network is literally, you know, it's kind of like a repeater, right? Where you've got a device here, and these are actually Meshtastic devices, by the way. This one's called the LilyGo T+. Looks like an old BlackBerry, for those of you who carry those. Although it's not nearly as easy to use as the old BlackBerries were. So I've got a radio here, and then I've got a radio here. So these are 2 users. They want to communicate with each other, but say they're miles apart, and they can't reach each other by RF because it's too far. So then you could have, you know, an intermediary device here. Now, if you think about it from the idea of a repeater, it's very similar, right? A repeater allows 2 low-power radios to communicate through a centralized repeater. So in a mesh network, it's not really a repeater that's typically in a fixed location and it's got power. It's yet another device. And so these devices are smart enough to know when they first turn on, they start to listen to see what all the different nodes that they can hear are around them. And they start to, and they have build an awareness of what they can talk to, and then through those nodes, they can then figure out what other nodes they can talk to, right? So it builds like a virtual map of all the nodes in the area and all the paths between that device and the other devices. And so in this case, a very simplistic example, whoever has device B, which happens to be in between and has contact with both of these, can proxy the message across, or repeat it, if you will. Right? So that's the simplest idea of a mesh. So as I discussed, a full mesh is kind of like the internet. So in a full mesh, every device has connections to every device. So it's technically, I mean, it's still a mesh, obviously, but it's not like a self-healing kind of thing. It can be, like in the internet, what happens is, like, say that this device needs to communicate to this device, and this connection drops. Now, that's what a router does, right? A router is smart enough, excuse me, to figure out that it can take a message from here, and if it can't communicate directly, it can send it through another router, and find a path, right? But that requires a whole lot of intelligence and hardware and all that to make that happen. Now, a partial mesh then kind of takes the other approach, saying, well, I'm going to assume that every device is not connected to every other device, but a path can exist one way or another. And those are called hops. That's a very important term in networking, right? So a hop is where, say, this device is trying to get to, I don't know, this device, and say this path doesn't exist. It can then see that, oh, like I can take a hop here, or multiple hops, to get from device A to device B. So that's really the concept there. And in the terms of a partial mesh too, it's not dependent necessarily on hardware in between. These are just radios that are communicating with each other, right? They're not, you don't have a router, you don't have a repeater, something that's fixed. It's all sort of a very dynamic kind of network, and the nodes just sort of sense which ones are out there and which ones they can communicate with. So advantages of a mesh network, especially the partial mesh, is it's self-healing. So if a node goes down, data can automatically be rerouted, to get to the eventual place where it needs to go. And that's only governed by the ability to get to that destination. And there's a setting in the radio, which you'll see in a little while here, where you can specify the maximum number of hops that a message can take. And so it defaults to 3. So that means that if you've got 3 devices in between you and your destination, you can still get the message through. But if it's 4 hops, it'll die. It won't go that far. And the reason that they let you change that is that as these meshes grow, like in a metropolitan area like Denver, I'll show you a map in a little bit here, but there's probably at least 50 nodes active at any given point in time. Wow. The record for a Meshtastic network was over 2,000, which was set last year at DEF CON. I keep talking about DEF CON. Yeah, they had a specific DEF CON network based on Meshtastic. They had over 2,000 nodes in Las Vegas all active at the same time. So if you think about that, if you have 2,000 nodes and you have all these nodes that are set for like 8 or 9 hops, can you imagine how much that increases the overall traffic? Right, so that's where you want to ramp that number down, because otherwise you'll get congestion. All kinds of bad things happen. It's decentralized, so no central router or hub is required. So basically every radio, every node is a repeater, if you will. And that's great from a disaster recovery, emergency communication type of situation, where if the entire infrastructure fails, you can still have a fully functional network, because all these little individual radios are all acting as the network. It's redundant, again, because you can have multiple paths. So if one path goes down, you can still use another path to get the message across. It's highly scalable, as I mentioned. You can go up to thousands of nodes. And it's all self-organizing, so they're all smart. They're capable of probing and listening and figuring out. And you'll see, in the demo where it's kind of cool, because they'll figure out each one of these devices can either have its location acquired automatically via GPS, like one of my devices has GPS in it, or you can actually specify the address. You just paste in your latitude, longitude, and so given that, it can figure out the distance, between the nodes, and then it can also figure out the signal strength and all that kind of stuff. It just does this automatically as part of the software.
Are these polled networks, or are they the other way, deciding who's there?
Oh, a polled network, you mean, as opposed? Yeah, it's a. That's a good question. The devices are constantly transmitting, so they listen to hear other nodes out there, but they're also paying their information out so the other nodes can find them, right? So it's kind of both.
So it's like an ACNet?
Yeah.
That's not always written on it.
Right. That sounds right. Yeah. Okay. So examples of mesh networks. So Wi-Fi is, especially the newer versions of the 802.11 protocol, the A and C. So if any of you have like an Ehr network or Orbi, anyway, any of these newer ones, those are a mesh network on their own. So you have, like in my house, I have 4 Ehrs, I think it is, spread around the house, and they communicate with each other. And as you're moving, your devices are moving around the house, like if you're walking from one end to the other and you're on the phone, which is using Wi-Fi, they'll actually hand off, right, as you move throughout the house. So that's a mesh network. And again, because there's, I guess technically with like the Ehr, there is a central device. That's the one that's actually plugged into your router. But other than that, they all kind of function independently. We had a presentation at TechFest on Eridan, the Amateur Radio Emergency Data Network. That's another example of a mesh. Very different from Meshtastic. A lot of people get confused, like, well, how is it different from Meshtastic? Well, we'll learn more about Meshtastic in a minute, but Eridan is built to be a high-speed network. It's based on Wi-Fi protocols, and so you can transfer, megabytes, gigabytes of data across these things at very high speed. So things like video and voice, all that stuff is supported. Whereas Meshtastic was designed just for text, and it's low speed. It's kind of a weak signal type of a thing, right? So we'll get into that in a minute. Meshtastic and MeshCore. So these are two, I wouldn't say they're competing protocols, but they both use the same hardware, and they both function very similarly, but they're different. Meshtastic was the oldest one. I'll talk about the history of these in a minute here. But they both use the LoRa, L-O-R-A, radio hardware. I forget what that stands for. I've got a slide, I think, that defines that. But this is kind of commodity hardware that's been around forever. It was originally designed for transferring telemetry, things like water pumps and temperature sensors and all that kind of stuff, right? And so it uses this radio hardware that's been around forever, running on very low cost, very inexpensive hardware, plus open source mesh software. And basically, it's just for text messaging. You can't send pictures, you can't make a phone call with it, but you can text up to 200 characters, typically. You can also share location. And I'll get into that in a little bit, too. And of course, I already talked about the internet being the largest real-world mesh. Everybody clear on what a mesh network is and how it works so far? Okay, history of Meshtastic. So 2019, a guy named Kevin Hester created an open source project, and his idea was to create an affordable mesh network to allow long-range communications without requiring any infrastructure at all. And it was all based on LoRa radio technology. His first idea was, and this is still the primary use case for this, was that he wanted to have an ability to communicate with his buddies when he was out hiking, without requiring cellular, without requiring radios. Just a simple text message, thing that would work at long distances, and again, with very inexpensive hardware. And then, as it began to grow in 2020 and 2021, because he open sourced it, a bunch of people jumped onto the project and started developing the software. And so it's been now in development for, 6-7 years, and it's continually being developed. So it's the most mature of the two. I'm talking about that versus MeshCore because it's the oldest. And then as it began to get more steam behind it, additional use cases started to emerge, especially around disaster recovery and that kind of stuff. And a lot of folks began to realize that there's more to this than just using it when you're out hiking. Right? You could do like a metro area mesh that would be there if everything else fails. Right? So kind of in that regard is similar to Eridan, but very different, right? Because obviously you're not going to be sending video over it. And then the hardware ecosystem matured. So they have begun to certify devices to work with Meshtastic. If you go to the website, it's just meshtastic.org, I think it is. They'll have a whole list of certified devices. And the devices typically run $100 or less. Every device that I have here today, I have 3 of them, was well under $100. This one here, unplug this. This one here was about $48. So, yeah, more on that later. All right, so let's see, yeah, and then they continue to evolve. One of the biggest things they added is this thing called MQTT, message queuing telemetry transmission or something. I forget what it stands for, but that allows you to, so most of these devices have Wi-Fi in them too. So they have Bluetooth and they have Wi-Fi. And then some of them also have GPS. So if you connect these to Wi-Fi that's connected to the internet, that then all of a sudden allows you to expand coverage. Because now you can optionally, it's not a requirement, but you can optionally use the internet to carry those messages between nodes. So all of a sudden, like here in Denver, you know, I can't, even with 5 hops, I probably can't reach somebody in Fort Collins. It's just too many hops. But if they're connected to the internet and using MQTT, I can easily communicate. More on that too in a minute. Okay, LoRa. LoRa stands for long range. Okay, that makes sense. Low power wireless communication technology. Uses spread spectrum modulation, so it's very resilient to interference and that kind of thing. And you can go up to 15 to 20 kilometers in open terrain with the right antennas. You guys are all familiar with how that works, right? It's all about the antenna and the terrain. Very low power. These devices, like this one here, will run, I think, at least 2 days on battery, maybe 3. And then it's got USB-C on it, so you can actually plug in a battery pack and it'll run, you know, or a solar panel, it'll run forever. Very low power. They operate typically on unlicensed frequency bands. In the US, it's the 915 megahertz ISM band. And you know, then in Europe it's different. If you're a licensed ham, you can also operate them on the 433 megahertz band. More on that later. And so LoRa, again, you know, as opposed to like Eridan and Wi-Fi or the other protocols, is it trades the high-speed networking, you know, the ability to do all that stuff for extended range and the ability to, you know, to penetrate through buildings and all that kind of stuff. So again, in that regard, it's very similar to weak signal like FT8, right, where it just will continually retry and retry and retry because it's only got a tiny little bit of data that it's sending. You know, it'll just keep trying until it gets certain. All right, yeah, so as I mentioned, you can transmit small amounts of data at very low speeds, 0.3 to 50 kilobits per second. It's pretty slow. And it could last months or even years on a battery charge. I don't know that you could go months or years. Maybe it's a really big battery. but yeah, again, it's great for, there's some analogs with APRS, right? Because you can send you know, little bits of data, right? So telemetry and that kind of thing. But it is not interoperable with APRS. And of course, the benefit is you don't have to have a license to do it either. Okay. All right, so Meshtastic, long-range off-grid mesh network using these little inexpensive, low power. This is a 1 watt unit. Most of them are 1 watts in capacity. Typically under $50. And as I mentioned, low-speed text messaging and location sharing, and it does not require any sort of cellular or internet. It's decentralized, so as I mentioned, each one of these is its own individual node. So I have like 3 of these running here in this room, and they're all talking to each other. They all know they're here, right? And they're also talking to other devices. There's somebody just a few blocks away who's a ham because he uses, I forget what his call sign is, but who has one of these. More on that later. You're not supposed to do that, by the way. If you're using unlicensed Meshtastic, you're not supposed to use your call sign as your node name because people think that it's licensed. Anyway. Open source and encrypted. So this is really interesting because most of the unlicensed bands, the FCC prohibits the use of encryption. So for example, if you're using FRS or GMRS, you're not supposed to use encryption, although many people do, but that's an aside. But in the ISM band, you can use encryption. I'm not sure why that is, but you can. And so Meshtastic does support encryption. So there's really a couple of ways you can communicate with it, and I'll show you more on this when we do the demo. But basically, you can either create a channel, which is sort of like a common channel for people of certain interests. So for example, I created an NA0TC channel, and it's encrypted. And the only way you can communicate with others on that channel is if you have the encryption key. Right? And so that makes it very nice for people who want to be able to communicate, but have it private. And it's very strong encryption. You can also choose to not encrypt the channel. And so there's the default channel, which is called channel 0, is not encrypted. So everybody anywhere that has a Meshtastic device turns it on, it automatically will work on channel 0, and you can communicate with anybody in range over that channel. You can also do node-to-node communications. So you can pull up a list of all the nodes that these radios are seeing, and you could say, oh, I see John's node over here. I'm going to send him a direct message. And that goes direct, and that's also encrypted. Let's see. Yeah, so obviously it's very good for emergencies and outdoor activities in areas. I know a lot of folks around this area like to use it because of SOTA and POTA. So if you're out hiking around with your buddies, you're going to do SOTA, and you don't want to have to keep talking over the radio, you could use Meshtastic to text each other. And the other nice thing about it is it's cross-platform. So this little device has a screen on it, but it's an itty-bitty little screen. And basically, all it shows you is the battery strength, and you can review messages on here. You can send responses, but only canned responses, because obviously there's no keyboard. But what you can do is you can connect to it over Wi-Fi or Bluetooth from an app. And so there's free apps available for Apple, Android, and Mac. There's no Windows app for whatever reason. And you can also communicate via a web browser, which I'll show you in the demo. And so it doesn't really matter that these devices don't have a display, because you can always use your phone, right, or whatever to talk to it. And again, you don't have to have your phone connected to cellular. It's just using Bluetooth or Wi-Fi. Yes, sir?
You just made a point, you said you could send a message directly to him.
Yeah.
But you said, and it'll be encrypted. So that means that you have been talking to him in advance to set the key up, right?
Yeah, so each node has an encryption key, right? And so when one node communicates to another, they exchange keys, right? It kind of happens as a part. It's the same way like when you're on the internet and you're using SSL, when you go like HTTPS and you connect, you exchange keys, and that's how they can communicate and be encrypted. Right, so this uses that exact same type of technology.
So the key is generated by the device, not
Right.
by you.
Exactly.
And therefore, he doesn't have to know what the key is.
Right.
Because his device does.
Yeah.
And it sets it up immediately when you said, I want to contact that particular number.
Right.
Then that connection is clicked, encrypted, and you don't see a thing.
Yeah, exactly. So just to paraphrase all of that, when you do a direct message from one node to another, when the first message goes across, that generates a key exchange. So his device has a key, which is built automatically generated when you start the device up. So you don't have nothing you have to do. But anyway, his device will send me his key. My device will send my key, and that sets up an encrypted channel. So as long as you're communicating, then that remains encrypted. And then when you're done, after a certain period of time, it just shuts down. Yes, sir?
Well, you say you're sending a message. How are you sending that if you don't have a keyboard on there?
Yeah, so as I mentioned, these devices can be used with an app, right? So you install an app on your phone, or you use a web browser on a computer to communicate over Bluetooth or Wi-Fi with the radio. So that's your user interface. And I mentioned with this one, you can respond, but you have to program in pre-canned responses. So like I have 10 responses built in here. So with the keys on here, I can select, like yes, no, okay, or call me or whatever. Right? Okay, good questions. All right, so let's talk a little bit about devices. There are, I don't know, at least 50 different Meshtastic devices available on the market today. They range from handhelds like this one. This was the cheapest one. I got this one through, I want to say, I don't know if it was AliExpress. I think I found it on Amazon, but it was about the same price as AliExpress. This one came as a little kind of a quote-unquote kit. It wasn't really a kit. Basically, they ship you a 3D printed case, an antenna, the board, and a battery. And you plug the battery into the board, you put the board in the case, and you close the case. So it's not exactly, oh, you have to put 4 screws in. You know, that's about it. So not really a kit. But yeah, this one was about $48. Or no, take it back, $39. I bought a set of 2. So they're usually typically very small. They have a little tiny little OLED display on them, which is just enough to see that, you know, that it's alive and what its battery level is, that kind of stuff. And then there's, on the other end of the range, devices like this one. This is the BlackBerry clone. And this one actually has a pretty nice touch screen. Let me fire it up here. Has a nice touch screen on it. It has a little ball like the old BlackBerry, which doesn't work very well. But anyway, and it has a keyboard. Right, so this is self-contained. So you can literally just scroll down and you can just hit, you know, message or whatever, and off you go. More on this when I do the demo. But yeah, this one was about $95. And took about 2 weeks to get here from China. This one came directly from China. And then this one here is the, oh wait, I got this little one here. And this is kind of in between. This one was designed more for outdoor use. It's a little more rugged. You can tell from the antenna, although that's not a very good antenna, but anyway. And it has an E8 display, which uses even less power than these OLED displays. This thing will go, I don't know, 3 or 4 days on a charge, easy. It also has GPS built into it. Right, so you can just throw this in your pack and use your phone to communicate with it, you know, and off you go. Yes, sir.
How are they powered? Hopefully you don't have to plug them into a USB port to charge them.
Yes.
Because that way if the power goes down, hopefully they use batteries you can...
Well, these, obviously you have to charge them somehow. And so they all charge via USB-C. They all have built-in batteries though, right? And so...
So you can't... If the power goes out, you can't recharge it.
No, that's not correct. USB-C is universal, right? So you can buy solar panels that have a USB-C output, right? And you can charge them from that.
Yeah, well, yeah.
So yeah, it's just everything's going USB-C. Yeah, I just thought for Christmas I got a bird feeder that's got a camera on it, and which is cool, really cool. And the camera has a USB-C port, and it came with a solar panel. And you just mount the solar panel pointing south, and then plug it into the USB-C on the bird feeder, and it runs it forever.
Yeah, you can buy USB-C, USB-A converters. I just bought 6 of them.
Right.
But I mean, still, if the power goes out.
Yeah, well, it's the same problem with any device. When the power goes out, you have to find alternate power somewhere, right? And it's probably solar.
But if they ran off of AAA batteries,
Oh, right.
you'd be much better off. But none of those will do that.
Not that I found. So yeah, the point was if they ran off of like AAA batteries, then you could just put new batteries in. But you know, yeah, I think everything is just going USB-C, and they're assuming that. I mean, you can buy a USB charger that you put alkaline batteries into, right? So yeah, there's ways around that. But yeah, these all have rechargeable. You know, I think they're all lithium polymer batteries in them. All right, moving right along. Then there's bigger units. So like this one. You'll see a few of these around Denver, like when you look on these devices, you'll see these things called solar nodes. And that's what these are. They're kind of like a repeater where people put a decent antenna up on their roof and a panel, and it's plugged in. And this is a weatherproof case. It's got a panel built right into it. And you just mount this up on your roof. And that actually is a really nice kind of a base unit. Now at my house, I have another one of these plugged into an AC adapter sitting in my master bedroom window. So this is my base unit. But anyway, at some point it'd be kind of fun to have one of those because they have much better range. And again, they're pretty cheap too, 110 bucks. You know, that's way cheaper than a repeater would be. And as you might guess, the one limiting factor for any of these is the antenna. These were all aftermarket antennas that I bought. And the nice thing is, of course, at 915 megahertz, I think this is a full wave antenna, might be half. But anyway, they're not very big. So this is supposedly a 10 dB gain antenna. I don't know if I buy that, but it's better than the one that came with it, which is about the size of the base of this thing. It's a little stub. It looked a lot like this one. So yeah. Anyway, so yeah, it's all about the antenna more than anything. These repeaters, or whatever you want to call these solar nodes, can also be set up to do store and forward, which means that if they receive a message for another node and that node is not online, they'll hang on to that message and they'll wait for a specified period of time. And if that node comes back online, it'll then forward the message on. All right, so that provides even more kind of resilience to make sure that those messages can get through. Now, as you might guess, on these little itty-bitty devices, store and forward is not a really good idea because they don't have much memory and they have even less CPU. So you don't want to do them on these, but the bigger units are perfect for that.
Mark?
Yes, sir.
Will they market these as like a base mobile versus handheld so you know what features are, or do you just look at the specs to see if you've got the store forward capability?
Yeah, that's a good question. Sometimes they mention that. Most of these will actually do store and forward. The question was, do they market these as a base mobile unit with store and forward explicitly defined? And they don't really necessarily say that. But most of these devices, like this one, for sure can do store and forward because it's a bigger unit and it has a little bit faster. This one's based on, I think it's the ESP32 chip. But again, it's sort of like if you enable it, you're not necessarily going to tax the CPU, but you're going to impact your battery life, right? So that's really the consideration there. But yeah, so these other units, though, like especially the solar ones, that are kind of self-contained, kind of by definition, will all do that. All right. Yeah, so obviously, I just got into Meshtastic. This all started because of a discussion on TechNet. Thanks, Rob. Appreciate that. No, it wasn't Rob that brought it up. I think it was Jonathan that brought it up. But like in November, right? And I think somebody asked the question, and I've been checking into it, but I hadn't bought any units. So, first about this one, I'm like, well, this is kind of cool, but I'd really like to have one that has a display. So then I bought this one, and then this is kind of cool too, but it's not really very rugged. So then I bought this one for hiking. Right, so it's like ham radios, right? They just start to multiply over time. So I'll help you kind of decide which one to buy. Maybe you don't need to buy 3 of them, but obviously there's dozens of them on the market at pretty much any price range up to about $100. So really, the thing you got to think about, is what you're going to use it for. If you want to use it at your house, you might put one of those solar nodes on. Or if you want to use it for mobile, you can also use one of those that way. And just run it off your car's battery or whatever. If you want to go hiking, then maybe one of these smaller units or the ones with a keyboard would be nice. One thing that bugs me, by the way, is none of these come with a belt clip. So you have to. This one at least has a screw, so you can, or a receptacle so you can screw something into it. But anyway, so really that's the consideration. Budget's usually not a big thing, like I mentioned. These are pretty cheap. The one thing I would recommend is get one with a built-in GPS, right? For obvious reasons, because especially if you're going to be moving around at all, you don't want to have to manually update location. Because again, that's one of the things that the algorithm uses is it requires the location, so that it can know how far away you are from the other nodes. Because if you don't have that, then the only other way you can gauge that is by signal strength. And if you're moving, that's kind of difficult. And then if you want to use your interface or not, if you're okay with using a phone or web browser, that's cool. Then you can get any of these. Literally every one of these has Bluetooth built into them. Every one of these has Wi-Fi. And so user interface is not a big consideration unless you want to use it standalone. Range. Now some of these, like you can buy this unit with an internal antenna. That seemed to me like a really bad idea. Right? especially at 900 megahertz, you want to have an external antenna, and especially if you're using it inside of a car without an external antenna. And these are cheap. I mean, I think it was $20 for 2 of these. They're very cheap. And they're just standard SMA connectors. And of course, if you want to use it as a base station, or you want to have off-grid capabilities, and getting a solar unit's probably a good idea. And then how you're going to access it. And there's this, by the way, this deck's already up on the club website. So if you guys want to get to any of these links, you can find the deck, the link to the deck up there. So a comprehensive list of supported devices on the website, and then you can just click in and look at the prices and all that kind of thing. Okay, let's talk about licensed mode. So as I mentioned, if you're a licensed ham, then you can use Meshtastic in licensed mode, either in the 915 megahertz or the 433 megahertz band. And there's a couple restrictions. Well, first of all, on the plus side, you can use higher power. So you can go up to 10 watts. Now, obviously, none of these devices are going to do 10 watts. So it's a special, more expensive hardware to do it. And as I mentioned, it'll use the licensed frequencies, but you cannot use encryption, right? Because it's ham radio. So you have to turn encryption off. You have to include your call sign, which you just put into the node name, right? And then when you have license mode turned on, by default, every 10 minutes it sends out your call sign for FCC rules. And the biggest disadvantage is there's no interoperability. So if you go into licensed mode, you're only going to be talking to other licensed Meshtastic users, right? Because it's typically, especially if you want to run 10 watts, it's going to be on 433 megahertz. And so you're going to have a completely different device than the unlicensed ones. So yeah, I don't know. I turned on licensed mode on one of my nodes and let it run for a while, and I didn't see anyone. So if that's an indicator, probably. Now, of course, if you're out, hiking with your buddies and you're all licensed hams, and that's a whole different deal. Then you can do that kind of stuff. Okay, let's talk about MeshCore. Here's another fun little graphic that I created in 20 seconds. So they are similar in that they both support short messages. They both use LoRa hardware. All 3 of these devices I have sitting here will run either one of those protocols, but they're not compatible. So MeshCore is a newer one. It started in 2024 in the UK, so it's very new. Runs on the same hardware, and there's also higher end hardware that I'm not sure what that really means. I haven't got that deep into it yet. I think it might be more oriented toward power users, maybe even on the commercial side, but we'll see how that develops. Because Meshtastic's been around for 7 years now, it has a much larger user base and lots of developers working on it. Yes, sir?
Now, is this going to take the place of like packet radio?
Question was, is it going to take the place of packet radio? Not in the ham world. I don't see that happening because that's a whole, that protocol has been around forever. But it is similar, right? Although a lot of folks, like if you go to the Denver Radio Club's packet radio site up here, it's like a bulletin board. And I don't see that ever happening over Meshtastic, right? It's just designed to do text communication from one person to another. So it's similar in some ways, but I don't think it'll replace it. Especially because packet radio is also required a license, right? Whereas anybody can use Meshtastic. Yeah, so there are communities in Denver now for both MeshCore and Meshtastic. DenverMesh.org is the Meshtastic group, which is funny because the website's DenverMesh.org, but they actually, if you go to the website, there's like communities, and there's Longmont, there's Fort Collins, and there's Western Slope. There's no Denver, even though it's DenverMesh.org. So I don't know what's going on there, but anyway. But there's a pretty decent active group there. They have a discussion channel on Discord. If you guys are familiar, Discord is kind of like, like groups.io or whatever. It's just a way of sending messages to other people over the internet. I did configure one of my nodes for MeshCore, and I let it run for a couple days, and I saw like 2 nodes. So again, it's just not, it hasn't gained steam yet. And I kind of already talked about this. There's another one. So now they're battling Eridan here. Eridan looks kind of evil, though. I think that's a Wi-Fi panel that he's got. Anyway, yeah. So again, Eridan, as I mentioned, completely different design, different use cases. Uses Wi-Fi over commodity hardware and so on. So I see them really as complementary to one another, right? So if your use case is you want to have a local mesh of high-speed communications for when the world goes south and you still want to be able to send pictures to your buddies or whatever, then Eridan is good for that. Or if you want to run VoIP calls or that kind of stuff without having an internet connection. If your objective is just to be able to send text messages like, hey, I'm alive, or whatever, then Meshtastic is going to be the quickest and the easiest way to do it, and cheapest way to do it. And as I mentioned, both approaches do not require the internet, but can use it if it's available, right? So in both cases, it just can serve as a way to extend those networks while still maintaining the resiliency. So if the internet were to go down, it would still work. Okay, MQTT. So as I mentioned a second ago, you can connect Meshtastic and MeshCore to the internet, and it's as easy enough as just basically putting the device on your Wi-Fi network, and you just give it your your username, your network name and password, and it connects to the internet. And then you have to go into the software and enable MQTT. And what that does is then all the messages that this thing can send or receive can also come over the internet. And of course, the benefit of that is extending the range beyond just a few miles or however many hops that you can go, right? And so basically, it's very simple. You just turn it on. There's a couple of nuances as far as how you configure it within the configuration of the Meshtastic, which I'll show you in a minute. You have to first turn it on, and then you have to enable it for each channel that you want. So you don't have to, it's not an either or. You can say, turn it on, but I only want it to go over the public channel or my private channels or whatever. So I'll show you how that works. And some people regard it as cheating, but whatever. If your objective is to be able to talk to people over Meshtastic, MQTT is a good idea, especially in an area like Denver where we're so spread out. Especially like I live down in this part of town, and there's a few, but when you're only looking at maybe a mile range, your chances of hitting somebody over RF are a little dicey sometimes. So MQTT is very similar to an APRS iGate, if you're familiar with that, and it's the same kind of type of functionality. All right, so DenverMesh.org, as I mentioned a minute ago, local group of Meshtastic users. This is the map I just generated the other day. So there's a surprising number of nodes out there and people using these things. I live down in this area. See this little alien? That's me. So when you configure your node, you could, if you default it, it'll have like just some kind of hexadecimal name in there. But you can, with the app, you can actually paste in an emoji into that, and it'll show up as your node. Anyway, so yeah, it includes a local node map and a Discord discussion channel. And they hold a weekly net, theoretically, which I tried to join last Thursday, and I didn't get anything, so I don't know.
Yeah, actually, I sent you that link.
What's that?
He's on my sent you an article about that New York City Police Department.
Oh, he's talking on the phone. Okay, he's talking to me. All right, getting started.
So how do they run the net? Have you ever
No, I joined it and I didn't see anything, so I don't know how they do it. That's a good question.
What was the question?
How do they run the net, the Meshtastic net? Because it's run over Meshtastic, right? So it'll be all text. So I don't know. That's a really good question. If I ever find somebody on there, then we'll see if it actually happens. So getting started, obviously the first step is you got to get yourself a device that supports Meshtastic. There's tons of them on Amazon. I have found interesting that the prices on Amazon are pretty similar to what AliExpress pricing is, maybe a few dollars difference. But of course, the difference is on Amazon you can get it in 2 days versus 2 weeks. Right?
And you can return it.
and you can return it? Yeah, good point.
Yeah, and you can return it. That's a really good point.
Mm-hmm.
Yeah, exactly. And then some devices come with the firmware already installed on it, but regardless, you're probably going to want to update it to the latest firmware anyway, because it's constantly being updated. I mean, like daily, sometimes there's a new version out there, just because there's so many people working on it. But the good news is, it's pretty easy to do. There's a web flasher. That sounds kind of weird, but anyway. On the Meshtastic website, there's a flasher site, and you literally just go in, and I have screenshots, I think, in a minute. But you just tell it what kind of device you have. Typically, you're going to plug your device in via USB into your computer, and then some devices you have to hit reset. Like this one, there's a tiny little pinhole under here. You have to click it twice to put it into firmware mode. Others, you just turn it on and it just automatically works. So it kind of depends on the device. That's really the most learning curve you're going to run into on these devices, is just figuring out how to do the firmware, because it's all over the board. Because there's multiple kinds of controllers built into these. Like this one is an ESP32. This one has, I think it's a Pi 2040 in it. And then this one has a different one, I forget what it's called, like an MRF something. And so they all have different ways to load firmware. But anyway, once you've got it in firmware update mode, you literally plug it into the USB and go to the website, tell it what kind of device, and it'll flash it. Now this is really important. Fortunately, it did not happen to me, but you have to have an antenna attached to the transceiver before you power it up, or it can burn out the finals or whatever it is that's in there. Yeah, definitely make sure you have an antenna on there. And then configure the device, and I'll show you these steps in a minute here. And then once you've done that, and configuration can be just as simple as putting your name into the node name, and because these things will come up and they're immediately communicating. So it can be really simple. Okay, so flashing the firmware. Again, I'm not going to go through every one of these. I immediately put this in here for your reference later. So if you want to download the deck, because you can learn from what I learned on how to do this. So yeah, for the demo, you could use like this one here. This is the called the Heltec V3, and basically these are all USB-C. So you just connect USB-C to your computer. In this case, you double click the little reset button to put it into firmware mode. Then you just go to Meshtastic, you figure out which kind of chip your device uses, and there's a whole list of them. Like this came right off their website, so this one shows exactly what chipset it's using. So you basically just click which device you have, and then the latest firmware is automatically selected, and then you just literally hit flash and it will update it. And it takes about a minute, maybe 2 minutes to do it. Okay, so once it's up, as I mentioned, as soon as it boots, it's already communicating. It's already sending its node name out. It's already listening for other nodes and so on. So web-based configuration is the easy way the first time you use it. You probably already got it plugged in via USB, and so you literally just connect it. You go to client.meshtastic.org, which is their web-based interface, and I'm going to do a live demo of this in a minute here. Click on New Connection, Serial, and it's a little bit of guesswork sometimes to figure out which serial port, especially if you have a Flex or one of those where you've got like 10 different COM ports. Here's a pro tip. One way to figure it out is plug the device in, go to your device manager if you're on Windows, and unplug it. You'll see it disappear. And plug it back in, see it appear. That's how you can tell which one it is. And then you just basically select that device, and then you get this gobbledygook. This is actually your device here. And you just click on that, and it takes you into the user interface. All right, so I'm going to step through this real quick here. So this is what the configuration looks like. Again, this is just a web-based configuration, so very simple. Again, you don't have to do a lot to make it work at defaults. I'm just going to step through a few things that you might want to know. So when you first start, see there's a navigation pane on the left here. You can click messages if you just want to go ahead and start sending messages. You can click map, it'll give you the node map. I'm going to show you this live in a minute here when I do the demo. And also the list of all the nodes that it's seeing. So 214 nodes is what my device was seeing just with this regular antenna. Now, that was with MQTT enabled, by the way, so it was using the internet to do that. And then you've got basically 3 different things you can configure: the radio, modules, and channels. So we'll just step through these really quickly. All right, so under the device, then about the only thing you have to do under here is there's a role. And by default, it's a client role, which basically means that you're communicating peer-to-peer with other devices. The only thing you might ever want to change to this is if you have multiple devices. So I have 3 of them here. And if all 3 of these were set to client, they could start to step on each other. And so there's a mode, I think it's called client mute. So that means it's receive only as far as communicating with the other nodes around, right? Because you only really need one node that's capable of talking to everything else, especially if you have one that has a really good antenna. And then the other 2 will just communicate locally with it. Because otherwise they're all 3 going to be kind of competing with each other. Yeah, so there you go. Client mute, that's what it is. And this is another one. It took me a minute to figure out. And the device, you want to set the time zone, otherwise it defaults to GMT, which is not quite as convenient. And so I found this on some web page. So I'll save you some time and just paste that in there, and that'll set it up for mountain time. This, I think, has daylight saving stuff in here. No, that's what all this garbage is.
Stop the mandates of daylight saving.
Yeah, exactly. Daylight saving, right. There's a position tab, and so as I mentioned, if your device does not have GPS, you might want to paste your latitude, longitude in there, just so that that will help with it, being able to figure out where it is and what it can communicate with. And then there's a network tab, and if you're not going to use it outside your home, you can go ahead and connect it to Wi-Fi. And that gives you a couple benefits. One, as I mentioned, is you can use MQTT to transfer messages. It also allows you to connect to the device via Wi-Fi. You literally just go to, like back here on this screen here, you click HTTP, and you just put in meshtastic.local as the host name, and boom, connects to it. Now, if you have multiple devices all on Wi-Fi, that's a whole different deal. We'll not talk about that right now. Anyway, and all right, so then there's a LoRa tab, and you basically just have to tell what region you're in. The hop limit, as I mentioned earlier, defaults to 3. I set it to 5, which gives you better chances of your messages getting through. And the Denver Meshtastic is only about 10% utilized, so it doesn't matter if you set the hop limit higher. Not going to affect anything. I'm going to take these devices to DEF CON this year, so it should be really fun. That ought to be an experience. This is kind of where there's these different modes. So like if you ever use FT8 or any of those weak signal protocols, there's like different modes you can use, whether you want to be able to have more resilience and slow and that kind of stuff, like WinLink has modes like that. This is similar, but everybody uses long fast. And the modes are not compatible. So if you select anything other than long fast, you're probably not going to hear anything. So don't mess with that one. Obviously, you want it to be able to transmit, and it defaults to 30 dBm, which is about a watt. Security tab is where all your security keys are stored. Those are all automatically generated, so you don't have to mess with that. But I would recommend you hit the backup key, which just will save a file on your computer with your keys in it. And I'll talk more about why you'd want to do that in a second. Then there's a channel config. Primary tab. So as I mentioned, you can have multiple channels. Channel 0, bless you. Channel 0 is the default system-wide unencrypted channel. So anybody can put a message out there like "Good morning" or whatever, and then communicate. I created an NA0TC channel. So if you have one of these devices and you want to join in on the fun, you just create a new channel. You make sure it's a secondary role. You paste in this pre-shared key, excuse me, and that will allow you to decrypt the messages coming in. So without this pre-shared key, nobody will be able to receive what's being sent. And then, of course, the name is just NA0TC. This is kind of important. You want to go into change device name. So your long name is whatever you want. If you want to advertise that you're part of the Denver Mesh, you can just put denvermesh.org on the end of it. So like my home node is, I use Wild for Gadgets for all of mine. So it's Wild for Gadgets, home, or base, I think it is, and then denvermesh.org on the end. And then for the short name, as I mentioned, it's a 4-character gobbledygook thing by default. If you want to, you connect in with your phone, you can paste an emoji in there, and pretty much any of the emojis you can find on your phone. So if you go into text messaging, like you're going to message somebody, and you find an emoji you want, you just copy and paste it. And there's all kinds of fun ones. And as I mentioned, don't use your call sign for your device name if you're running in unlicensed mode. And I think the software now actually tells you not to do that if you try to paste it in there. Okay, MQTT, I kind of already talked about. Configuration is pretty simple. First of all, you just got to make sure you're on Wi-Fi and you're connected to the internet. You go into the radio LoRa option, and you just hit on for OK to MQTT. And then there's an actual module on the left side called MQTT. Just make sure it's on. These should all already be in there as defaults, but if they're not, they're in there in case you need them. And then this is important here. This root topic, basically just when it's transmitting out over the internet, it just limits it to Colorado. So you're not going to be going nationwide. We definitely don't want that kind of trouble, right? So yeah, that'll just limit it to Colorado.
Mark,
Yes, sir.
on the Wi-Fi, do we need a login and password?
Yeah, when you connect for Wi-Fi, it'll prompt you for your network name and password. Yep. I think it'll even actually scan and you can select which one you want to use. And then the last thing you want to do is for each one of these channels, and remember, so there's, like on mine, I have channel 0, which is the public channel, and channel 1, which is NA0TC. You have to go in each one of those channels and turn on MQTT for those channels. Then it works. Operating is really simple, just basically 2 ways, technically 3. There's public channels, there's private channels, and there's direct messages. So public, again, that's channel 0, goes to the entire mesh. There's the private channel, which is that NA0TC one that I created, or you can create one for your family or whatever, your buddies you're hiking with. And then there's direct messages. So with the direct message, you just, you have to know the person's node name that you're trying to reach. And then you just select it and you hit send a message and type it in. It's just like sending a text, up to 200 characters. And let's see. Oh yeah, and then as I mentioned, if you have a unit that has a display but doesn't have a keyboard, you can create a list of short messages and you just basically say like yes and then a pipe symbol, that's the vertical bar, yes, no, okay, on the way, whatever you want to have in there. And you can have up to 200 characters of those. It'll just give you a pick list. Okay, so let's move to the fun part. So this one was a little hard for me because I wanted to show a couple of hams that were hiking that were texting over a mesh network, and this is what Google came up with. It's kind of weird, especially because like there's a radio there, there's a radio there. I specifically said that they're texting, but it looks like they're talking, and there's another antenna up here too. So I'm not sure what I was trying to do, and it came up with a slogan too. The ham's new favorite SMS.
That's why it's artificial intelligence.
Yes, artificial. Right. Okay, so let me show you this demo real quick here. All right, John, I can scoot in there.
They look like they're happy.
Yeah,
Yeah, well, they're hams. Of course they're happy.
as long as they don't jump.
Yeah, yeah, right. That is a good point. All right, let's hide this and go over here. Okay, so as I mentioned, this is the Meshtastic interface. And so on the left are your main things, so here's your messages, right? So, yeah, so here's the ones that are coming over channel 0. So here's the channel here, primary is channel 0. So here's somebody, just some random person, hello, copy you in the old, wherever the old north end is, 30 hops. You can also go to the NA0TC, and this is where John and I were sending messages to each other. Let me grab one of my devices here. There you go. John just sent one. do the same thing. So on this one, you know, I can literally just click the message.
Is this a web interface to your device
Yes, exactly.
via the Wi-Fi?
Yeah. Well, Bluetooth in this case.
Bluetooth.
Yep. Yep. So there's the one I just sent from my T-Deck. See on there?
And the app just looks like a regular text,
Yeah.
like you're texting back and forth.
Yeah, very easy. Once you get it set up, it's pretty straightforward. Yeah, so that's messages. You know, if I want to send one out to the great group sync kind of thing, I just say, you know, hey, hello from Liquid.
If I can type.
There we go. And send. And off it goes. Yeah, so that's really all there is to it, sending and receiving. You can, from the devices too, there's also an option to exchange location. So if you select that, it will send your GPS, and this is pretty much only when you're just communicating with another device, not system-wide. But it'll send your location out, and then the other device will send its location back. So here's the map of all the nodes, and you can zoom in.
This guy's everywhere.
Yeah, that's, I was thinking too. So what's the throughput? Get a gigabit per second out of this?
Throughput, the question is what's the throughput? No, it's like 50 baud. So yeah,
Seriously?
like CW. CW's some CW operator might be faster. No, it's not very fast. And because you're going from node to node to node too, sometimes it can take a while for you to get a response, right? Because it's just kind of popping all over the network. But anyway, so yeah, like here's me, and this particular device I'm connected to is the flying saucer icon. I'm not sure. Oh yeah, and then this guy is just a nerdy smile face. Now these both look like they're in different locations because one of these is probably going off of the IP address of the Wi-Fi it's connected to, because this one does not have GPS in it, whereas this one does. And then if you go down here, see, we can find my home node here. Yeah, see the alien? That's my home node. Anyway, yeah, so any one of these, if I want to send a message to, well, there's a mouse. I can literally just click on it. And then it'll show me the details on it, you know, how long ago I heard it, how many hops, their altitude, their signal noise ratio, and so on. So yeah, as you can see, there's quite a few nodes in the Denver area. And we just need to get a few more so that you know you don't have these huge gaps like in here, you know, where obviously nobody's going to be passing any messages. Yeah, so that's the map. The configuration, as I mentioned, is really straightforward. You just click on config. Here's all the main things for the radio modules and channel. So this one, as you see, is set for client view because that's not my primary device. And I've got it set for, this is where the hops are. You know, yeah, there's the time zone I was telling you about. Yeah, position. In this case, fixed position off. Yeah, I think that one does have a GPS in it. But if you don't, you can just click on fixed position and then paste in a latitude, longitude. Power I talked about already. That's pretty straightforward. Again, you don't have to mess with most of this. Network, here's where you enable Wi-Fi. So you would just click enabled and then type in your network name and password. So like in this case, I can put in, you know, the bridge church network if I wanted to. And that's about it. Just display stuff. This is all stuff you don't really need to mess around with. LoRa, yeah, so US is critical, because that way it picks the right frequency. Hot plummet, again, you can pick whatever you want in here in Denver. If you do not want to use the internet, turn this on, otherwise leave it off. And in this case, so this device is configured to be standalone because it's not on Wi-Fi, so I have the MQTT turned off. long fast is the default. You definitely want to use that if you want to talk to someone, because that's the only one that people are using. And there's Bluetooth. When you first fire up the app, these devices will automatically be in pairing mode. So you literally just, I wish I could show you my actual app, but you literally just hit connect and it will go out and search for the devices, and you just pick the one and connect. And then usually what will happen is it will give you a 6-digit code on the display of the device, and you just have to type that into your app, and then it pairs and off you go. And the user interface is very similar to what you're seeing here. And then lastly, security, as I mentioned, you don't have to change anything in here. Just hit backup key to save a copy of all this. And the reason you want to do that is that when you update the firmware, one of the options is to do a complete erase, which will erase all of your keys. And so if you do that, which I don't recommend you do unless there's a really good reason for it, but if you do, you're going to need that backup file to be able to restore your keys. So definitely want to have a copy of that. Other than that, module, here's MQTT. So, you just check that to enable it. And again, it's already got all the defaults in here. So as long as you're connected to the internet, literally you just turn it on. And the rest of this, you can leave it alone. And the rest of these, I don't think you need to mess around with. Oop. And then on channels, all right, so here's all the different channels. So as you can see, I only have 2 configured here. These are all just defaults. Primary is the one, again, that's the system-wide unencrypted channel, and you don't need to do anything with that. And then here's the NA0TC, and you can see I put the appreciate key in there, and that's what allowed all of us to communicate over that channel securely. And that's about it as far as the configuration. It's pretty straightforward. And again, just messages. I don't have any responses to this one yet. Now, see how this guy said 3 hops? What you can do, I'm not sure you can do it on the web. Yeah, I don't think you can. But on the mobile apps, if you click on their node, it will show you how many hops away they are. And so that's where he got that 3 hops from. Other than that, oh yeah, there's a, if you go to the Denver Mesh website, you can also get a node map there. That's kind of cool. And just so you know, you go to click on Colorado and there's no Denver. I don't know why. It's just kind of weird, but anyway. But yeah, here's the information on their weekly net. And so it's just on channel 0, the default, at 7 o'clock, and that's about all it tells you. Yeah, so I'm going to keep trying. Apparently they had 20 check-ins. That wasn't, well, I was not one of them. Anyway, and I thought, oh, here's the map. So this is kind of cool. Whoops, because this is worldwide. It's hard to do with one hand. So look at that. There's over 1,000 nodes, and that's just in looks like Western U.S. There's 2,000 in the right side, right 2/3 of the country. 4,000 in Europe.
This is almost 11,000 worldwide, I think, down at the bottom.
Yeah, that's about right. Yeah, and so you can actually, zoom in on these too, which is kind of cool. So yeah, pretty cool. And obviously, this is using the MQTT to gather all this information.
There aren't many in China.
Yeah, funny how that works. That's where they're all manufactured.
Yeah, I know. That's what I was thinking about. Is they're making them like crazy, and yet they can't use them.
Right. Yeah, probably get arrested when they do it.
Enemy of the state.
Yeah. So yeah, John's going down to Florida. Yeah, there's a few down there.
Quite a few.
So anyway, yeah. So John, when you get to Florida, make sure you put your node on Wi-Fi, and so we can try to do a multi-state communication.
Okay.
All right, that's pretty much it. Any questions?
With your GPS-enabled one you took hiking, who did you communicate with?
I have yet to take it hiking because I literally just bought this one.
Okay.
So
Who do
no
you
one
plan
yet.
to?
Well, like, if I can get some buddies that would also buy these. I don't know, it might be really interesting though, like if you go up to, the top of Meshtastic, however you say it, Chief or Squad, one of those up there, you could probably have really good line of sight from up there. So, it might be fun just to do it solo and see. But I know like Corey McDonald, he's big into soda, and I think he either has some or was going to buy some. Dan also has some Meshtastic, so yeah, we just need to organize a little field trip and try it in the field. Yeah, so far, the one thing that's kind of frustrating is there's no guaranteed delivery of messages with this network, right? And so you can send a message out there, and you never know if someone actually got it or not. You do get an acknowledged message, but that just means that one node acknowledged it. But that doesn't say that it actually made it past that node. So it's kind of, again, as these meshes get more and more built out, they'll get more reliable by default. But yeah, it's not a guaranteed delivery like with SMS. You just aren't really sure until they respond, then you know. But anyway, all right. Well, any other questions? Yes,
Why would somebody want to use one of these?
why would somebody want to use one of these? Well, because they're a cool gadget.
50 baud, it reminds you of
50
your
baud, yeah,
teletype.
it's like your childhood. No, like I mentioned, it's like one guy, he and his wife have these, and when they're at the store and stuff, they play with them. I don't know. Maybe if you're at Disney World or something, but you just do texting on your phone. So yeah, I think it's the main use case are geeky folks that like to hike or spend time in the backcountry that want to be able to communicate, and without a radio, especially for like hunters. That was one use case I read where, when they go hunting, you don't want to be squawking on a radio, right, because you can scare the game away, right? So with Meshtastic, you can do it silently.
Actually, that's
Right.
If people put up enough nodes.
Well, if you've got a group, like you're a hunting party, right, and you're all within a few miles of each other, that's a perfect use case, right? Because then you've got a built-in mesh.
Of your own.
Yeah, exactly.
I talked to a Civil Air Patrol pilot that said, wow, built-in GPS,
Uh-huh.
no other radio needed. Stick that on the windshield of the airplane. And they can always
I'm
find
glad you brought that up. I got a message about a week ago from an airplane. What Mark said was that he talked to a pilot. He goes, yeah, built-in GPS. All you do is stick it in the window, right? And you've got a built-in, node. But yeah, people are doing plane-to-plane Meshtastic. I've seen this happen. Now that's illegal on all kinds of levels, right? But you're only transmitting a watt, so people are doing Wi-Fi on planes now, so whatever. But yeah, I
It
got
would
it.
only be illegal on a commercial flight though, right?
That's true. Well, I don't know if that's an FCC or an FAA regulation, but anyway. But yeah, a guy was on a plane from Philadelphia to LA, and I received his message on my little device. So, and that would be, I'm going to try it, the next time I'm on a
Yeah,
plane.
absolutely. That's,
I'll let you know as soon as I get out of jail. How that. But, no, I mean, it's pretty cool, because yeah, the people that plane-to-plane Meshtastic, because when you're that high, it could work.
I used to use my VX5 on aircraft
Yeah.
until they, wised up and wouldn't let me use it anymore.
Yeah, right. Yeah. But yeah, that's a really interesting use case. I'm definitely going to try that. All right. Any others?
Yeah, what is the one that's in the middle of the Gulf of, is that America?
The Gulf of Mexico, America?
Yeah.
I mean, oil rig.
Yeah, probably is an oil rig.
Yeah, probably is. Let's see if we can zoom in on that.
It's like in the middle there.
Could be a long distance swim. Somebody on the ferry.
Tactical satellite AI. I'm guessing that's somebody who set their location manually. Because otherwise it probably would be receiving.
2 minutes ago.
Yeah. Yeah, in fact, I've seen that guy in Denver. So yeah, I think he's probably. Yeah, that's part of the problem. You can set your location wherever you want it to be. Whatever. All right. Well, yeah. So if any of you guys decide to jump in and get a node, definitely set it up for the NA0TC channel and put a shout out. And it'll be kind of fun to see if we can get it to work. But otherwise, yeah, I'm looking forward to trying it up in the mountains and seeing how, and on an airplane, and see how it works. All right. Well, thanks.
Jim's presentation.
Did anybody not sign the roster?
What's that?
Check in?
I didn't.
Good job. Thanks.
Jim's slides.
Oh, yeah, I'm sorry. Jim had some slides he was going to present real quick. I almost forgot. Switch over.
This will be about 5 minutes on pico blooms. Does anybody want to hear about that?
Sure.
There we go.
Yeah, I know it. No extra charge.
All right. How do you switch?
How do you switch the slides?
It's back here.
Um,
Make sure it works. Yeah.
There we go. I'm involved with Edge of Space Sciences. So there's a, and remember that, Edge of Space Sciences. At the end, it'll be important. But this is, I use the theme here of party balloons because what we've done is launched a balloon, and it is a party balloon, and the intent is to make it across the Atlantic Ocean and maybe go all the way around the world. The party balloon itself is something that you buy from Amazon, 2 for $9.99. And that's, I'm pre-stretching it there in my Radio Shack before we launched it. But people have tried this particular balloon and it works well. You know, ultraviolet protection and the gas not leaking out are important issues.
What gas do you?
We filled it with hydrogen. Edge of Space Sciences has lots of cylinders of hydrogen around, but a lot of people use helium. Some people use a hydrogen generator, home generator that you use for cosmetic purposes. And he says, the wrinkles on my face have not decreased, but it flies well with the balloons. And then for a transmitter, it has, this is a unit that's built by Bill Brown down in Huntsville. It's solar powered, 2 solar cells. It has an Arduino ARM processor on it, and they use the trick of just oscillate the pin on the processor. Has a GPS on it, and then down here at the bottom there's a low pass filter to filter out all the square wave stuff. This has a connector on it right there for testing purposes, but you desolder the connector. And this is a 20-meter whisper transmitter. And it has a whole 20-meter dipole. The balloon's up on top, half the dipole, the beacon in the center, and then the other half of the dipole hangs down below.
So the PC board goes in the center? Or?
Yes, the PC board transmitter goes in the center.
Interesting, okay.
This whole thing only weighs half an ounce.
Okay.
It's a 0.6 millimeter board. It's all small components. The solar panels have the no backing on them. They're just strictly plastic. And anyway, put this whole thing together, fill the balloon with only a little bit of hydrogen. It's carefully measured how much. But here we are getting ready to launch the balloon. The 20-meter dipole comes down. That's me holding the beacon in my left hand there, right hand, I think I'm facing toward you. The rest of the antenna out there. And then we let it go. It goes up fairly slow because it only has, that's a 500-liter balloon, and it only has about 80 liters of gas in it.
Expand as it gets
But as it goes up, it
exactly.
expands
Yeah.
until it finally reaches about 46,000 feet, at which point it's tight. The balloon is strong enough that it doesn't burst, and it just floats along at that altitude. As it floats along, it's solar powered, so of course it only transmits during the day, and then at night it's still floating along, so the blue lines are connecting the dots between, and these red are actually a whole series of little dots. It transmits every 10 minutes. And it transmits on whisper, and the neat part is that there are whisper receivers all around the country that receive the 20-meter whisper signal, and then they put it out on the whisper net.
So where can you track
server?
it? On a web browser?
Yes, you can. If you go to Whisper and you put in the call sign, I'll show you how to track it at the end, right here. So we launched it from Colorado here, and it floated along, and it transmitted during the day, and then it floats along at night. And then it headed out across the Atlantic, and it had a nice long series of transmissions right there, and making its way over to Africa. Continued on around the world. Here it is coming back across the Pacific Ocean. There's Hawaii. Worked its way across the Pacific Ocean back, and then when it got even with Colorado, when it got to the same longitude where we launched it, I said, okay, we've made it around the world once. And this was actually yesterday, but this is actually the 5th time that this balloon has made it around the world. So this one has continued around the world, and there's a map of all 5 of its circuits around the world.
And China hasn't shot it down yet?
No, and for some strange reason, it goes right over Beijing every time. Well, not every time, but Beijing is right in this bay right here, I think. And it goes right over there. Once we went over North Korea, North Korea, of course, does not allow amateur radio. And so the processor is geofenced to actually turn off as it goes over North Korea and then start up again when it gets on the other side. There's actually 3 countries in the world that don't allow amateur radio in the air. One of them is like Somalia or something like that. One of them is North Korea. And the other one is England. I think it must be left over from World War II, but I think the regs are about to change, but they don't allow amateur radio in the air. The guys that fly balloons over there use unlicensed frequencies.
Do you think they would do something about it? Is anybody paying attention?
Probably not.
Okay.
Okay. When it was flying along and it got over here in the Mediterranean Sea and it got over near Israel and Lebanon and that hot area over there, all of a sudden, this is an altitude plot. It was flying along at 1,400 meters, which is about 46,000 feet. All of a sudden, zip, it's on the ground. It sits on the ground for about 3 days transmitting. Now, if it really burst and went down to the ground, it isn't going to lay on the ground and transmit, or people be able to receive it. But it sat on the ground for about 3 days, and then all of a sudden, zip, it was back up over central China, flying along. And what this is somebody over there is spoofing the GPS on the system and making it look like it's somewhere else. And the pico balloon, there's probably 30 pico balloons up flying around the world right now, and other people see this exact same thing. One of the guys that I know actually does a bunch of work, radio work with Israel, and every time I talk about this, he just clams up and sits there stone-faced. So I think I know what's going on.
They say this is a big problem.
Yes.
GPS.
In fact, here is a plot. This was just a 1 day, or actually a 1 beacon transit, but it was flying along over Turkey. All of a sudden, zip, it's sitting on the ground at the Queen Ali International Airport in Amman, Jordan. Don't know why, but it's right at the airport. And then zip, it's back up flying along again. So, interesting.
Whose base map is that?
That's
Is that
TSA.
open?
Oh, that's probably open maps.
Okay.
Yeah. One thing about this is, as you follow this thing, you sure learn your geography. I know the difference between Kazakhstan and Uzbekistan now. Okay, and final slide here. We actually have 3 pico balloons flying along right now. This balloon, number 2, was launched back on October 18th, and it is in the process of completing its 8th circumnavigation around the world. EOSS P3 and 4 were launched on October 25th at the HamCon over in Grand Junction. And this one has completed its 5th circuit around the world. This one, we have not heard from it since December 11th. It's about 22 days now that we have not heard anything from this, and this was where it was at last time we did hear from it. So a couple of possibilities. Number one, it got caught in a thunderstorm, taken down. 46,000 feet is above the top of most thunderstorms. The big ones are up high enough. And possibly it was taken down and is either on the ground or most likely in the ocean and gone. The other possibility is that those solar panels look straight up. And if the sun angle is not up high enough, it doesn't generate enough power to actually transmit a signal. Yeah?
What's propelling, is it the jet stream that's, are you using for around the world?
Actually, we're above the jet stream. Jet stream is usually about 35 to 40,000 feet. We're up at 46, but yeah, we're in the air currents in the upper atmosphere. One possibility is that it went into the drink. The other possibility is that it has gone up north far enough that the sun angle never gets up high enough to generate enough power for it to transmit. We have seen these balloons actually disappear for about 8 days and then reappear when they come back down from the north. So my hope is that this thing is wandering around up in the Arctic somewhere. And sometime, and some people have experienced a couple of months before balloons have reappeared. And maybe it'll come back. I think next time we launch one, I'd like to put the solar panels at more of an angle, so you got a lower sun angle to it. But that means during the midday you wouldn't be getting as much power. And this all has to do with weight. You got to keep the weight as low as possible. So we'll see. But anyway, this guy's been gone for 21 days or so now. But that's currently what we've got going. So if you want to track these things, there's a big long URL that you can go to. But keep this in mind. If you go to the Edge of Space Sciences website, eoss.org, and then you look down through the various flights, you'll see EOSSP-2, and I'll tell you how many times we've gone around the world. But if you go to 3/4, there is a link in this page, right at the top of the page, and it says, click here to track the balloons. And it's a real neat link. Save it, and then when you click on that, it'll show this map of where all 3 of the balloons are.
Could you put that back on again, please?
Yeah, but EOSS.org, that's the thing to remember. Yeah?
I noticed you didn't have any enclosure around your PCB.
Correct, nothing.
Because you don't want the weight. Do you have any problems with weather, or do you somehow protect the surface of the...
No, it's not treated anyway. It's not...
Oh, that, you actually, the board is flying naked?
The board is flying naked. Now,
I think it would get contaminated or something.
Well, on the way up, there's a possibility of it
Leakage
picking up
currents and
moisture or picking up ice if it goes through high-level clouds. But at 46,000 feet, you're in the stratosphere, and the humidity in the stratosphere is quite low. In fact, a couple of these balloons do have a humidity sensor on them, and they show like 5%, 10% humidity. Okay? They show also minus 50 degrees C.
You did say that sometimes storms are up that high.
Yes.
It's just rare, so you just go with it if it happens.
Yep.
They'll dry up. I mean, at that altitude, even if they got wet.
If they got wet going up, right, they might suffer and then dry out once they got up there. Yeah.
Jim, my wife and I were with you at HamCon when you launched those, and she had a question for me that I couldn't answer, and I told her I would ask you next time I saw you.
And I may not know, but I'll make something up.
What is the record for the length of being able to track any of these balloons that you have launched? What's the longest?
Well, this is our longest experience here.
Okay.
We're right at about 100 days with that P-2. There is a couple of people that have flown balloons, and their record is about 950 days. That's about 2.5 years.
Wow.
Wow.
So I'm amazed that plastic can withstand ultraviolet.
That's impressive.
Yeah.
How do you avoid aircraft? Are you a boat?
How do we avoid aircraft? We don't. We hope the aircraft will avoid us. What's the probability of the balloon and an aircraft being in the same place? Is pretty low, although there was a 737 that hit a weather balloon about 6 weeks ago, and it shattered the windshield. They didn't lose pressure, but that was a bigger payload than what we've got. The other thing is ours weighs a half an ounce, and the balloon is plastic, and it has the antenna wire is number 34 magnet wire.
Wow.
So it's pretty fine wire. But if it got sucked into an engine, it might break the blade. I don't know.
I doubt.
But it's not going to bring the plane down. If it wrapped around the wing.
So could you put a slow scan camera pointing down at the ground with?
Well, if you could keep it under half an ounce.
Well,
Actually, there are some guys out in San Francisco that are doing slow scan TV off of a beacon like that.
Because it seems like with that kind of time, if you could figure out somehow to carry it, get the weight down.
The problem is having enough of a signal strength or signal link. The guys that are doing slow scan TV now, if you're within about 50 miles of it, they have been able to receive a reasonably decent picture from it, but far enough away.
Yeah, and USS used to send packet. I used to work packet to USS balloons.
Yeah.
in the old days.
And APRS is our standard method of tracking it. Now, but those are heavier beacons that weigh on the order of a pound.
Yeah, I was going to say, are you thinking about going larger?
Well, if you go with the idea here was economy,
right?
How to keep it affordable for folks like us. You can go with a bigger balloon to try to get more weight, but then you've got more gas, you've got more balloon to deal with.
So what did you spend on, like the balloon, the printed circuit board?
The beacon packet, the beacon we buy from a guy in Alabama, and he charges $169 for that. But he includes the solar panels, the antenna, advice on how to do it, and so for $169. So what we're saying is we can come to your elementary school. It'd be about $300, but we can put together we can do a launch. And what I'd like to do is get together with the kids, explain what it is, launch this thing out in the field with them there, and then they can follow this over the weeks while they're building payloads to fly on the bigger balloons for Edge of Space Sciences.
So what's the guy's call sign or the?
WB8 ELK.
Oh, yeah.
Bill Brown. Elktronics.com is the name of his company.
Well, I would imagine once it gets to altitude, he's at 46,000, right?
Yeah.
Yeah, I mean, that's above commercial aircraft.
Right. There are some wide bodies that sometimes fly up at that altitude, but we have to pass up through the flight lanes.
Do you have to notify the FAA that you're launching?
Not on something this small.
Oh, okay.
Edge of Space Sciences does notify FAA on all our big latex balloons that we fly, and we are now flying ADS-B beacons that the planes can actually see, and air traffic control can see.
Oh, that's cool.
They cost
cool.
$6,000 each. That's a different story. But this thing is small enough, and it's exempt from all the FAA regulations.
So do you have any idea, how are they spoofing the GPS?
All I can figure, spoof the GPS, all I can figure they do is they transmit satellite signals, or signals that look like the satellites, strong enough that it overrides the minus 115 dB signals coming down from space.
Wow.
And that's why the thing goes to the ground and then it just sits there for 3 days.
Right.
Even though we're sailing along and we're sailing along and transmitting, but every time we transmit, it's that fake GPS, that fake satellite signals coming out. It's the only way I can figure it. And like I said, the guy I know that does this sort of stuff. He doesn't talk about it.
So you transmit data?
About the only thing it transmits is temperature, relative humidity, and its location.
Do you get those signals when it's spoofed to the ground?
Yeah, was sitting on the ground, transmitting that. Right, the temperature all of a sudden is really wacky. It's not minus 50 degrees C, it's plus 20 degrees C. At some point I envisioned maybe it had come to the ground and was hanging in a tree.
You really did think it hit the ground?
Where it might still be transmitting, but I don't think there's any trees in Amman, Jordan. So I haven't been there, but I'm sure there's, yeah. There have been situations where these things have come down and they lay on the ground or they hang in a tree and transmit for days and days. Now it's interesting. The whisper packet, is only 24 characters long, and normally when you transmit whisper, you transmit your call sign, your four-digit grid square, and your power. And so with this, you can fake the 4-digit. Well, you want to give the call sign, you want to give the 4-digit grid square, and then instead of the power, what he does is encodes the temperature into that. Now it's a temperature, it's only every 5 degrees or something like that. But you want to transmit more information, so what this actually does is it puts out a second whisper packet that has a fake call sign. There's no call signs in the world that start with a 0 or start with a Q. So what it'll do is it'll transmit a whisper packet immediately after the first one that has a Q call sign, and then it has encoded in the rest of that call sign the other 2 digits of the grid square and the temperature and the relative humidity. So if you can get both of those together, and I have a Python script that's running on my computer at home, that every 10 minutes it goes out and it scrapes the whisper database. And if it gets those 2 packets, it puts them together and it creates an APRS packet that it actually puts out onto the web. So that link that I gave you, if you go to that, you'll actually be seeing an APRS packet that's been put together either by my script or the script that Bill's running down on his machine. So,
so you're converting the whisper into EPRS and
yes,
putting it out.
Yeah, so that everybody can easily see it. And this one balloon that disappeared, haven't seen it for 21 days. Notice here how all of these are flying along at about the same latitude. If they got up any higher, they weren't reporting. In fact, some of these weirdosities, I think over here, is where it actually went up here. We didn't hear from it, and then when it came back down here, we started hearing from it again. Let's see, where was I going?
So why do you think you didn't hear from it when it was?
Because the sun angle never got up.
You're just talking about power charging. And
yes. So we're hoping, in the summer, the sun angle is going to be more advantageous. So hopefully in the summer we'll see it. What was I going to say about this guy?
So it seems that you got 2 panels. Couldn't you order?
Well, but then you increase the weight.
Well,
yeah, angle them.
Yeah,
angle
one vertical and one horizontal.
Well, but then you only get half the power. And the thing actually does have a couple of supercapacitors on the back of it. And so those panels will charge the supercaps. And then the hope is that there's enough power there to be able to transmit the 2 whisper packets. And then actually there's a third packet that's on that uses JT9, which is one of the WSJT protocols. And what Bill Brown does is he looks around the world where the balloon is, and then he goes to a remote SDR in that location. In fact, he was listening to one in Japan, and then feeds that into FL Digi and decodes it there at his house.
Wow!
And that gives a 8-digit grid square, which tells you very closely where it is. But anyways, things are flying along, and one of these days we'll launch some more, but hoping that these keep going for a good long time.
Jim,
Yeah.
Jim, losing the word I want, but try to get people here to be interested in joining the USS.
Edge of Space Sciences, yes. Well, that's why I'm doing this. Come on out with us, and we launch about 15. We have about 15 balloons a year. Big latex balloons that go up to 100,000 feet, pop, and then come down in eastern Colorado. Student experiments on those, bring the students out. But
When's your next launch?
April.
Okay.
April will be the next launch.
Do you intentionally pull those, or does that just naturally happen?
It naturally happens, although we do have mechanism to be able to terminate the flight if we need to.
What do those go to, 107,000 or something?
About 100,000, 90 to 110,000 feet. But these were specifically designed to go up to just 46,000. The higher the better, but with the weight trade-off, that's about as high as we can get. Somebody in San Francisco, a group, they're getting them up to about 60,000 now. I don't know what kind of balloon they're using, but the hobby is progressing.
What's the typical ground speed of them?
Ground speed, they go usually on the order of 80, 90, 100 miles per hour in the wind. Although one time we were floating along over here in the Pacific Ocean, and it was going 23 miles an hour. And I commented that at that rate it's going to take us a long time to get across the Pacific. And it did. Our first lap around the world took 23 days. And now things are speeding up and are happening in about 12 to 14 days.
So is that dependent on time of year then?
No, I think first time it was unlucky and it actually got caught in some doldrums out here in the Pacific Ocean. It actually went around in a circle out here in the Atlantic, and then when it got in the Pacific, it got into some really slow stuff. And that might be a winter thing, but definitely the sun angle is a summer thing.
Are there any equivalents in the southern hemisphere?
Yeah, some of these balloons will cross down into the southern hemisphere, cross the equator, get down to the southern hemisphere. Unfortunately, there's quite a bit more weather down there, so much more likely of hitting thunderstorms down there.
Interesting. Hey, Jim, what's the difference between the blue and the red? Is there more transmissions with the red?
The red is where it transmits.
Oh.
The blue is connect the dots during the night.
Okay.
It's asleep.
Yeah, it's asleep. And those red are actually a whole series of red dots that are 10 minutes apart.
Okay.
And you can see that the winds must have been blowing quite rapidly here, because in one day there was a lot of travel that there. Maybe that was.
So what's the 20-meter
And
frequency?
that's a sharp knee on that too.
Yeah, and well, during the night it probably went up like this and then curved around and came down.
Okay.
Yeah. What's the frequency? Look up the whisper. This is the standard 20-meter.
Oh, it is?
Whisper
Okay,
frequency.
I guess you said that. Yeah.
And actually, this balloon, number 4, is on the 17-meter whisper frequency. And I have tuned my radio at home over to 17-meter whisper and received it directly. Yeah.
Being fairly new to this, what is whisper?
Whisper is a weak signal propagation reporter, and it's a 2-minute long transmission of 4 frequency, but it's a low signal that can be received over a long distance. And you can go to Whisper and actually see these packets directly if you want. But this one is actually on 17 meters. The other two are on 20 meters. And we've come to the conclusion that the 20-meter Whisper frequency is pretty crowded. And since this thing only transmits at between 12 and 15 milliwatts, the signal is pretty low. And 17 is much more regular and reliable. So we'll be transmitting in the, I've ordered ones on 10, 15, and 17 meters. And I've got two meter beacons as well. So we'll be trying different frequencies. Okay, that's what I've got. Thanks.
Yeah.
Yeah, the Whisper's pretty cool. You can do it with a PC and a radio. I hit Antarctica on Whisper on a 1/2 watt, just using a regular wire antenna. It's pretty cool stuff. All right, guys. Well, we'll see you next month, if not sooner.
Thank you. Yeah, probably. I zapped the deck and it went blank. Oh, now it just woke up again.